And now we want to try to measure something like a transmission of an optical fluoride glass. And in the software, what we'll be doing is changing our application from voltage to transmission. That's going to perform a ratio when it's collecting data. We're going to confirm our sample chamber is set up. We haven't moved anything, so the detector is still positioned at 180. The sample's at 0. The range is correct. If I begin a scan right now, I'm prompted for the name of the reference file, which we just saved. It's important to remember what you call it. But before we say OK, we're going to want to check our hardware and make sure we have a sample in the beam that we want to measure. So in this case, I made a note that we put a calcium fluoride window in position 3. So we're in position 3. That material is now in the beam and ready to be measured. And having done this, we can say OK, and the instrument will slew down to the beginning wavelength. At this point in the operation, it's important not to hit cancel or close. You might realize, you say, oh, I forgot to set something up, and want to cancel this, but when it's slewing to its start position is a dangerous time. The instrument will lose its calibrate. It will lose its reference to its current position, basically, and you'd have to re-zero or recalibrate. Once the data acquisition process has begun, you have data point 110, data point 111. You can cancel without losing position. So if you think you wanted to start over, be a little bit patient and don't hit cancel until data acquisition has begun. I can make notes that will get recorded with the data. We can see here that below 115, where there's no real signal coming from the deuterium lamp, I have kind of a spurious signal here. And once there's actual signal detectable from the lamp, this locks in at a very, very low transmission, very close to 0, effectively 0 really, for the calcium fluoride material. And that increases as the wavelength increases. So we've finished our wavelength scan for the calcium fluoride window, and this is roughly what that looks like. It's through a spike here. I don't know if that's from the reference scan or from the scan of the material, but this sometimes happens when if somebody bumps the table, for example, or if the floor underneath the instrument isn't concrete, isn't stable. If there's some deflection, it's a sensitive instrument, and so care needs to be taken to keep its environment free of vibration and any sort of undue interruptions or bumps. Otherwise, things like this can happen in the data set.